Alright, so you've made your optic in Blender, but now you want to make a reticle for it, but you don't know how to do it accurately. And you don't want to do the classic thing where you just paste it on the glass and it just hangs there, because that's wrong and you should never do that. Well, here you go. This is a tutorial. I've looked all around. I can't find a tutorial for this. So I just had to piece it together using tutorials for other things, and I finally figured it out after a long time. So I'm making this video just to help people out, and also because I'm tired of seeing people do this. It's a big pet peeve of mine. But anyway, I know people like fast tutorials. I like fast tutorials too. So I'm going to split this into two parts, all right? The beginning of this video is going to be the fast version. You can just kind of copy everything you see on the screen. I won't really explain any of it. And you can, if that works for you and you can figure it out from there, then there you go. You can stop watching the video at that point. But if you're still confused, if it still doesn't work for whatever reason, then you can keep watching and I'll go more in depth with everything. All right, but anyway, this is the effect we're trying to mimic, where the reticle is not visible outside of the optic window. The reticle is not visible from the front of the optic, and also the reticle, it looks as though it is like projected from the distance, right? So it's like it's deep within the housing, if you will. That's the effect we're going for. If you've ever used a reticle or like an optic in real life, then you know what you want, but maybe you just don't know how to get it. This is how you get it. All right, so you're going to copy this material setup. The main thing is the parallax effect, which is all within this node group. So you can go ahead and pause the video and just copy this node group. And I will also, this is like all the group information if you want to do that. Then you're just going to plug that into your image texture for your reticle. You're going to mix that with transparent and emission. Also, you're going to want to enable these settings. It's worth mentioning that this is for Blender Eevee, not Blender Cycles. It does technically work in Cycles. I can quickly show that off. It does have a little bit of some weirdness there, but it does technically work. You could figure out how to fix that if you really wanted to use this in Cycles. But I'm using Eevee. And it works great in Eevee. But if you're using Eevee, then you're going to need to copy these material settings. If you need to open this window, you just press the N key. What else? It's important that the plane on which your reticle is like the material of, you have to keep this perfectly flat. It can't have any curvature to it. It can have, the perimeter can be curved, as you can see here, but the face of it has to be perfectly flat. And it's also good practice to keep it 90 degrees. You want to keep it perpendicular to the mounting axis, if you will. So like here, I've got it on the Y. So, it's rotated 90 degrees on the X. There you go. That's the fast version. If you did all that, if you copied all that, you paused it at interval moments, and it still doesn't work, then I'm gonna do the slow version now. I'm gonna kind of go through the process from the start and show you how it works. But yeah, if that's all you needed, then there you go. I'm glad it worked for you. It took me a long time to figure out how to do this, just because it was really hard to find tutorials on it. Because what do you even search for? I was searching for how to do optics in Blender, and it just never gave me a result that I wanted. So I figured it out after piecing together multiple different tutorials, and I'm just going to put it all into this one tutorial to help people that specifically want to make optics, because that was the main thing I wanted to make using this parallax effect. So there you go. But we're going to go into the slow version now, all right? So like I already stated, the things we're trying to mimic when it comes to the reticle are, there's three main things. The first main thing is that it's not visible outside of the window of the optic, and that even includes this, this area between this protective shroud and the window of the optic. And then the second thing we're trying to mimic is that it's not visible from the front. That's a mistake I see a lot of people make, is they do something like this, where the reticle is just pasted onto the glass and it's visible from both the front and the back of the optic. That's really not how they work at all. That would be really terrible if you were just constantly emitting your location to your enemy with a big bright light. And it's just also not the way that optics work, the physical properties of an optic and the light, being projected and everything. That's just not how they work. So you can't see it from the front. Don't do that. And then the final thing is, like I said, the parallax effect, where you know, effectively the reticle is just, it's like pasted onto the target, if you will. Like it doesn't seem like it's actually within the bounds of the optic itself. It seems like it's pasted onto something in the distance. So that is the effect we're going for. And we've got it here. So let me show you how it works. We're going to, first of all, I'm just going to disable that. So there is currently, you know, no reticle in the housing. And we're just going to start from scratch. So I'm going to put my cursor at the world origin, which is probably where yours is. Also, your scene might be scaled differently. I always recommend that you work like in true scale. So like the optic here is like true scale. You know, it's not like massive or anything, but you know, consistency and everything. But yeah, anyway. So we're going to add in a plane. And you're going to want to shrink this down so that it fits within the window of your optic. So in this case, we need to shrink it down quite a lot. If you shrink it down in object mode, it's going to affect the object's scale properties. So you can get around that by either just scaling in edit mode, and you'll notice that that doesn't change. Or if you do scale in object mode and you change these, you can always hit Control A and apply the scale, and that will set it back to 1. We're going to drag that over here, and I'm going to go into solid view, and I'm going to show something that's important because we're going to use this later on. If I turn on face orientation in the viewport overlays, you'll notice that one of the sides of this plane is red and one is blue. The blue is the outward facing normals, and the red is the inward facing normals. You'll see that the optic is all blue because we are looking at the outside of the optic. If I go onto the inside of the optic, you'll see all the red. It's important that you point the blue side of this plane towards the shooter. So you want the blue side to be facing the shooter. In this case, the optic is meant to be looked through in this direction. You know, it's more of like a holographic style of optic. So we want the blue side to be facing over here. So to do that, we're going to go into edit mode. And we're going to rotate this -90 on the x-axis. For you, if you are doing a different orientation, maybe you modeled in the opposite direction, then you would go +90. Or if you modeled in like this axis, you would rotate on the y-axis, you know. But in this case, we're rotating -90 on the y. So you'll see what we have is the blue face on this side, red face on this side. And that's exactly what we want. So there you go. And then we're just going to position this inside the window of the optic. So the window of our optic is this section right here. I'm going to go ahead and turn off the face orientation overlay because we just don't need it anymore. And I guess I can make this section a little bit bigger. Our window is this area right here. We don't want anything outside of it. And you also don't want to make it smaller than the window. You just want it to take up the entire window. So in this case, we're going to scale it on the X a little bit. And you'll notice that we have some corners that pop out here. That's not an issue. What we can do is, I mean, you can just select these two if you want, because these two at the bottom here are perfectly fine. But for the sake of this, I'm just going to use all four. And you can hit Control, Shift, and B to bevel the vertices, and we're just going to bevel those. Now, you don't have to make this like super high res or anything. You can just get away with just the two if you want to. But I am going to do more because why not, you know? There we go. So something like that. And you'll notice that if I highlight it, it all stays within the bounds of the window. It doesn't go, you know, it's not inside the window, it's not outside the window, it's just within the window. That's just what you want. And again, we are perfectly flat on, you know, the face. The face is perfectly flat, and we are 90 degrees. We are perpendicular to the mounting axis of this optic, which again is on the Y. So yeah, that's what we want. And that's the modeling done for this effect. What we have right now looks like this. It's just white because there's no material on it, but it's visible from both sides. And there's thunder outside. I don't know if you can hear that. You might be able to hear that. We've got a bit of a storm coming through, but don't worry about that. Anyway, we're going to add a new material because everything from this point on is going to be for the material. And right off the bat, I can showcase why it was so important to, you know, orient the face in the direction that we did, because in Eevee, and actually I believe this is in Cycles too, you have an option called backface culling. If I have this over here, and again, if you don't have this, this is the shader editor down here. If you just go to, you know, I could have a 3D viewport, or you can make this whatever. I made it a shader editor. If you don't have this on the side of your shader editor, just press the N key and it'll open up, and then you want to come down to the Options tab. We have an option here called backface culling, and what that does is it means that the back face of any face is not rendered from that side, but it is still rendered from the other side, which is exactly what we want. So this way you'll be able to see the reticle from this direction, but you won't be able to see it from this direction. So that's very important. The other settings that we need to change are the blend mode, because we're going to be working with transparency. So we can't use opaque. I don't recommend using alpha clip. It does still technically work, but it's just a bad way to do transparency in Eevee. So I never recommend using that. Your only two options are really alpha hash and alpha blend. And that's just going to come down to personal preference, because they both kind of have their positives and their negatives. Alpha hashed is more physically accurate. But alpha blend gives a slightly better look, in my opinion. It's a little cleaner. So it's up to you. Once you're finished with the effect, you can toggle between them and see which one you like more. But I like to use alpha blend, so that's the one I'm going to be using for this tutorial. As for shadow, you're going to want to set that to none, because the reticle doesn't have a shadow. And as for the rest of these, it doesn't really matter. So you can just leave those as is. There we go. I'm going to make the shader editor window a little larger so you can have a better idea of what I'm doing. We're going to go ahead and delete the principled BSDF because we don't need that. What we do need is a mix shader, because we are going to be mixing two shaders. All right, the first shader is an emission, and the other shader is a transparent. So we're going to plug the transparent into the top shader input and the emission into the bottom. And we are going to plug the shader into the surface. And what we get is something like this. It looks pretty similar to how it did before. Again, because alpha blend is not physically accurate, if I set this to fully 1, it should be fully emission. There should be no transparency, but there still is, because it's not physically accurate. But that is perfectly okay. Don't worry about that. All right, so that's good for now. And now we need to bring in our texture. Now the texture is just going to be the image of your reticle. I will show you what mine looks like in just a second. So that is my texture, and I'm going to set it to sRGB because that's what it is set to by default. If I come over here, this is my UV editor, and I just pull up the image. This is what my image looks like. So this is a 500 by 500 image. It's just a simple mask where white is what the reticle is and black is going to be transparent. If you've ever used any kind of material setup in Blender, you've probably used a mask before, whether it be one that you've made yourself or just using one of the procedural textures that come with Blender, like the noise texture. It's the same process. So yeah, simple 500 by 500. I recommend when you make your reticle image that you save it in a lossless file format, because you don't want compression. There will be artifacts. I don't know if I have. Yeah, I don't. I have saved in JPEG before, and it creates a lot of artifacts around here that will mess up how it looks. So I recommend saving in PNG. You don't really have to worry about file size, because the image is so simple that it's not going to have a large file size anyway, especially when you save in just 500 by 500. Now, to be fair, the reticle does have a slight amount of pixelation that you can notice with this image size, so you might want to bump it up to 1000 by 1000 if it's something that you think you're really going to be seeing all the time, maybe you're doing a first person animation or something. I don't know, it's completely up to you. I think 500 by 500 is perfectly adequate for what I plan on using it for, but you might decide otherwise. Just keep in mind that larger textures use up more VRAM, so you have to kind of weigh the benefits of the slightly higher fidelity, because are you going to notice it? Are you going to notice the difference between 1000 by 1000 versus 500 by 500? Now, to be fair, both 1000 by 1000 and 500 by 500 have a pretty negligible effect on VRAM usage, but if you're working in a really big scene and you need all the VRAM you can get for other stuff, it might be worth it to drop it down to 500 by 500. I find the 500 by 500 is fine for me, so you do whatever you want to do. Anyway, so you've brought in your texture for your reticle. It can be a simple dot, it can be more elaborate like this, it can be literally whatever you want. That's kind of the fun part of this whole process, is that you can make the optic or the reticle look like whatever you want. There's plenty of other real life companies that have kind of gone crazy with it, with biohazard symbols and They've made some pretty crazy reticles over the years. But anyway, so you've brought in your image texture. This is what the node will probably look like. By default, it's probably going to be set to sRGB. You're going to want to set that to non-color. That just tells Blender that you're using it kind of like a mask and you don't intend to like interpret the colors in any specific way, other than just like black is 100% black and white is 100% white. And if I plug this into our factor, which is what we're going to be doing with it, you'll notice that it's stretched out. In our picture, the circle is perfectly circular, but in our object, you know, it's oblong. And that's just because our UVs are kind of messed up. So to get around that, you're just going to go into orthographic view so that you can like see the face. And we're going to press U to unwrap it. And we're just going to project from view. Now that's going to kind of like mess it up. It's going to be really small in your window. That's perfectly fine. You can just scale it up. We're going to end up moving this later on, so it doesn't really matter where this is right now, but I'm just going to move it around for the sake of the tutorial to help you guys with some stuff. If we leave everything as is, you'll notice that there's a lot of reticles. I can boost up the emission just so you can see that a bit better. We don't want that, obviously, we just want one reticle. So to get around that, you're going to want to change this repeat on the image texture from repeat to clip, and that'll just make it the 1. So that's exactly what we want. And then as for the emission color, that just becomes the color of your reticle. Obviously in real life, reticles are pretty much only ever red or green, but you can make them whatever you want. I'm just going to go with red for this tutorial, but you do what you want. If you want to get like really precise with it, you can just go to RGB, because you're probably on HSV, which is hue saturation value. If you go to RGB, you can just turn off the red and green so it's perfectly red. Yeah, there you go. And that's pretty much like where a lot of people stop, right? This is like, okay, yeah, I mean, it looks like a reticle, but it's not good enough. That's not how reticles look in the real world. So we have to work on the parallax shader. So that's what we're going to do. We're going to move a little bit over here. I'm going to make this a bit smaller because we don't need that anymore. You're going to need a decent amount of room because we're going to be putting in quite a few nodes. So just give yourself some room, and we're going to start working on the parallax shader. All right, so the first thing we're going to need is a geometry node. And right off the bat, I'm just going to say, I have no idea what like any of this means. When it comes to like the shader editor and like nodes and like math and stuff, no, I'm just not smart enough for that. Like I said, I've kind of pieced this all together from like multiple different tutorials. I'll link a video of a person that's like way smarter than me that actually understands what like all of this stuff means. So if you're actually really interested in like how this all works and why it works, you can go check out that video. I don't know how it works or why it works. I just know that it works. And so that's just how I do it. If you want it to work, just follow along and it will work. But we're going to need a geometry node. And then we're going to need a tangent node. These are both in the input section. When you hit if you hit Shift A, I mean, I assume you guys kind of, this isn't like a super like beginner tutorial, I guess. I don't probably have to say that, but Shift A, you go to input, and we're looking for tangent. We're going to switch the tangent to UV map. And then we're going to bring in a converter, vector math, and we're going to do cross product. Sorry, I don't know how like zoomed in I need to be for this tutorial, like how well it's going to show up on your screen. Depends on what screen you're watching this on, I guess. Anyway, we're going to do the cross product between the normal of the geometry and the tangent. And we can just bring that down here. Then we're going to duplicate our cross product, but we're actually going to change it to a dot product. And the first dot product, we're going to do a couple of these, but the first one we're going to do is between the normal and the incoming of the geometry node. Then we can duplicate this, and the second one is going to be from the incoming and the tangent. So incoming from the geometry and then the tangent. And then the third one and the last one is going to be from the incoming and the cross product. Just like that. All right, now we are going to bring in a combine XYZ. So you'll go to converter, combine XYZ. And we're going to pull from the second one, the one that is in the middle of these dot products. We're going to go to the X, and then from the bottom one, this third one, we're going to go to the Y, and the Z just remains empty. Then we are going to bring in a divide, so that's going to be a converter, a math, and we're going to set it from add to divide. We're going to bring the top dot product, and we're going to bring that down to the bottom here. We're going to plug something into this value, but we'll only be able to do that once we group all of these nodes, so for now just leave that empty. Then we're going to duplicate one of these dot products again, and we're going to set this one to divide. Actually, no, sorry. We're going to set this to scale. We're going to scale this by using the combine XYZ vector and plugging that into the vector. And then we're going to use this divide and plug that into the bottom input there. Then we're going to bring in an input UV map. We can just put that above the scale. And then we're going to duplicate the scale and set it to a subtract. And we're just going to subtract these two from one another. So the UV goes into the top slot, scale goes into the bottom slot. Then we're going to duplicate the scale again. We're actually going to leave this one as scale, and we're going to plug the subtract into that. I think I might need a little bit more room here, so I'm going to drag all this a little bit over. Again, we're going to put something into this, but only once we've grouped everything together. So for now, you can just leave that as empty. Then we're going to duplicate the scale. We're going to set this to add, and we're going to plug that into the top one. Now for these, you're going to set these two top ones to 0.5. And that's basically it. That is our parallax shader, or parallax like vector, I guess. So if we plug this in without grouping anything, you'll notice it moved. It kind of looks a little weird now. But essentially, this value becomes our depth. So as I increase this value, you'll start to see the parallax effect take shape. And then this value becomes the size of our reticle. So you'll see I can make it larger or smaller depending on that. But yeah, that is the effect. So we're going to unplug that, and then we're going to select all of these and hit Control G, and that's going to make a group. This just makes it easier to use in the shader editor. It just consolidates everything. So we have a group output, and we're just going to plug our vector into that group output. And if you come over here, again, this is the N key to open this. You're going to come over to the Group tab. And if we click on the output, we can rename that. We're just going to call it Parallax. And then we've got our group input. You're going to take one of these inputs and connect it to the divide node that's underneath the combine XYZ here. And we're going to take the other one and we're going to plug it into the scale over here. And we can rename these. You want the top one to be like your reticle depth. You can name it whatever you want. I'm just going to call this distance. And the bottom one is going to be the size of your reticle. I'll just call that size. But again, you can call it whatever you want. And that's basically it. To get in and out of this group, you're just going to select this node and press tab. And when you're inside of it, you just press tab again. And there you go. One last thing I forgot to mention that you can do. This is not necessary per se, but I like to do it just because it gives you a little bit more control over the size of the reticle. You can duplicate this divide node and just plug it in here between the group input for size and the scale node over here. And you just want to divide this by like a big number. I do like 50 or whatever. And that just gives you a little bit more granularity over the size of your reticle. So now all of that is in one node, and it's really easy. You can just plug that in. And we've got a distance. The reason it looks so small is because it's actually really big, and that's just the center dot of the reticle. You'll see, there we go. And we can put it off in the distance, and that is our effect. So that's basically it, but if you want to keep watching, I'll give you a few tips on things. I guess one more important thing that's actually pretty, like, you're not quite done yet. We're going to want to go into edit mode for this mesh. And it's pretty important that you position this UV precisely. You want the origin point to be in the direct center of this like UV. So what we're going to do, Your cursor is probably already at the origin because that's where it is by default, but we're just going to hit Shift S and do cursor to origin to ensure that it is there. And then with everything selected, we're going to Shift S again and do selected to cursor with offset in parentheses. And that's going to do exactly what we want, which is put that in the center. That just makes sure that the reticle stays within the center of your window. And if you go into orthographic view, you can see that our dot is in the center of our window. If you want to, you can change like the vertical position. I kind of prefer to have it a little bit lower than center, but it's completely up to you. I'm going to do something like that. The scale of your UV map doesn't really matter because you're going to be using the size for the size of the reticle here. So yeah, you don't really need to worry about that. So that's basically it. As for like little tips and other things, you know, one thing that I've found, because like you'll notice, while this is the effect we want, it isn't quite being replicated perfectly right now because, you know, let me just quickly, I'm going to bring in a cube and I'm going to push it on the Y 100 meters. So that cube is 100 meters away. If we go back into here and we look through the optic, you'll see that there's a lot of like drift. This is in the world of like firearms and optics and stuff. This is actually called parallax. And it's kind of funny because I mean, the effect in 3D is called parallax, but in the real world, you don't actually want parallax on your optic. That just means that there is a drift between the thing you're aiming at and where the reticle actually is like pointing at. I believe most optics in real life are parallax free, in quotations, at about like 100 meters or 100 yards or so. And so with our cube there as a point of reference, you can see that it is certainly not parallax free at 100. I'm just going to select our plane. I've found that a distance of 1000 on the node group here, on the parallax node group, is pretty good, and you'll want to affect the size of your reticle so that you can actually see it at that distance. But yeah, as we move here, you'll start to notice that there is basically no parallax between those two objects, so that is good. Again, you have your strength here, so if you're doing like a night vision scene, you'll want to set this really low because the person would be using a really dim optic or like a really dim strength setting, right? Or if it's like a really bright daytime scene or something, then you'll want to set it like really high. You do you. So some other things that might be important to know are, so I assume like on your optic, you're probably going to have some glass, you know, either on the front or the back. This is a closed emitter style of optic. So it has both a back pane of glass and a front pane of glass. If you do that with your optic, you might notice that the reticle is not visible through that glass, and I can replicate that here. So this might be the effect that you're getting. If that's the case, it probably has to do with the fact that you're using transmission for your glass material. And a limitation of Blender Eevee is that you can't see refractive surfaces through other refractive surfaces. So to get around that, all you have to do is drop your alpha value of your glass material. Right now I have, you know, the glass material selected for my optic. So when it's at 100% opacity, you can't see the reticle at all. But when I drop the alpha, it becomes visible. So it's a pretty simple fix. If you want to get a little bit fancier with it, I have kind of like a layer weight going on here where, you know, the more directly you're facing the glass, the more transparent it is. And then the more like an angle that you look at it, the more like shiny it is. You don't have to go that fancy with it if you don't want to. I mean, it's really not that fancy in all honesty. But yeah, that's the simple fix. So if you're having trouble, if it's still not showing up for whatever reason, that's probably what it is. Also, in order for that to take an effect, you will have to change the blend mode for the glass material to something other than opaque because you probably have it set to opaque by default. So you'll want to set that to either alpha hashed or alpha blend, because if I have it set to opaque and I try to drop the alpha, you'll notice that the reticle still does not appear. You have to set this to alpha blend or alpha hashed and it will appear. Again, Don't use Alpha Clip. Alpha Clip sucks ass. Um, what else? What else? What else? I feel like I'm forgetting something, but I don't know. That might be it. That might be it. Oh, I guess in terms of like making it so that this material, stays with the optic. So we have our plane here, and this is actually what the reticle is on. So if I move this out of the window, now it's just up here. You obviously want this to be like parented to your optic. You can do this in one of two ways. So you can either just join it to the object. So now they're both part of the same object, and you can see they'll move together. Or if you want, if the optic that you're parenting it to, is using like an armature, like this one is, then you can just parent that plane to the armature and leave them as separate objects. There's not really a benefit to doing it one way over the other, but it's just up to you which way you want to do that. I recommend changing the name of the material to something like red dot reticle or something like that. I don't know, it's up to you. You can even change the name of the plane if you plan on leaving them separate. But other than that, I think that's basically it. When it comes to the reticle itself, you can do whatever design you want, and that will change the design of the reticle. And again, you can change the color and everything there. Yeah, I think that's basically it. Oh, I guess really quickly, I can just show off different use cases. So if you are doing more of like an open emitter design, what you'll want to do, I've just duplicated this. So obviously with an open emitter design, you only have one pane of glass. So what you'll want to do is just place the plane that has the reticle material on it. You'll just place that around where the glass is for that reticle. I recommend putting it in front of, or I guess a better word is beyond. You want to put it beyond the back side of the pane of glass. But it's really up to you. It doesn't matter that much, in all honesty. But I'm going to put mine about there. And it's not perfectly shaped, so, you're going to be able to see it outside of the window, but I just don't want to have to do that for the sake of this tutorial. But you would shape it to the size of your window and everything, just like we did before, and it would work exactly the same. So you can see here, the reticle works just like you'd expect, and it's not visible from the front. So there you go. That's how you do a reticle in Blender. Hopefully you learned something. Hopefully I helped you. If you've been looking for a tutorial for this for a really long time like I have, then I hope this was helpful. Anyway, thanks for watching, and I'll catch you later.